Hello everyone, this is a report for Team 25. Our team members are Linling Guo, Amit Parliwo, Jaewoo Park, Xuexian Qin, and Edik Simonia. Our project is to build a client-side application that can triage a patient and can track the progress of that patient. The application must take the triage results and assign the patient a severity level. The higher severity patients will have higher priority to be seen by physicians and nurses. For the patients that have same severity, it will be a first in, first out. The main users of our applications are RNs or other hospital staff at the emergency department. We have two use cases. The first one is for checkup for new patient that enters into the hospital, and use case 2 is for fetching patient progress report. The left side of the slide is our prototype diagram. The two use cases are separated by 1 point and 2 points. We have 6 steps for use case 1 and 3 steps for use case 2. The rectangle are components and the ellipse are our database. The components will communicate through REST and the WebSockets. Our data structure is queue-based. Patient information will be sorted in either one priority queue or different queues for different severity levels. We have 2 separate databases, patient data and hospital staff data. These 2 databases will be used to track available hospital staff to attend to patients and to track patients' progress after admission. Now let's see the details for use case 1. The patient information will be entered through the triage front end, and then the information will go through our ranking algorithm at the back end. The ranking algorithm will then prioritize the patient and add the patient to corresponding severity bucket. Patient information will then be added into the queue through the producer. The consumer components will receive the patient information and match the patient to available staff and the doctor based on the severity level. Once the patient is allocated to a doctor or staff, the patient information will be added to patient database. Now let's see the details for use case 2, fetching patients' progress. The hospital staff operating using our triage application will request for patients' progress. This request will be handled by patient's progress component. The patient's progress component fetch patient's information from patient's database, and then the patient progress components will return the information back to the front end.
I'm going to take over and record the technology and languages we will use for this particular project. On the client side, Reactive, TypeScript, and Webpack may be used. On the server side, Python, Fast API, or Flask, or OpenAPI are the good choices. For the database, MongoDB or Elasticsearch and RabbitMQ are the things we are going to use. For the continuous integration, Drone, Docker, Helm charts can be used if applicable. So this is the deployment pipeline. When a committer merges changes to release branch to GitHub, Drone will pick up the changes to the release branch via webhooks. This can register and update the Docker image to our centralized image repo. Drone will make sure the build will pass all the requirements. This is a CI test. After that, we'll deploy with K8s to HDAP, and application request will be made through Nginx or Uvicorn. For this slide, I'm going to show the UI mockups. This is the login mockup on the top that shows the URL for login, and this requires a username and password to sign in for the emergency department triage and resource management system. This slide shows the mockup for the resource management. When the patient is called in, he or she will be assigned a bed, although whether it's bed 1 or bed 5, and then will be assigned to a nurse or then a doctor. The more important thing is we'll decide the level to accept the patient. There are multiple levels, whether it is resuscitation, emergency, urgent, semi-urgent, or non-urgent level. So there is a priority to call in the patient. On the right hand is showing the patient's history. The patient will have a unique identifier. This is very like to the patient's insurance ID. Then the patient name, date of birth, age, gender, whether he or she have some known allergies, and whether she has some past medical conditions will be on this card. As I mentioned before, so this slide is a dashboard mockup that is characterizing how we define the severity levels of the patient for their emergency situations. We have different levels that we quantify them from level 0 to 1 to 2 to 3 to 5. For level 1, when the patient needs resuscitation, the average wait time, for example, is 5.3 seconds. The next level 1 is an emergency situation. Average wait time is 29.3. For level 2, it's an urgent situation. Average wait time 25.18 seconds. Semi-urgent situation, wait time even longer. And for the non-urgent situation, and it's over 1 minute, 25 seconds. So that when the patient call in, for example, with the patient 001, if it's a very emergency situation, we'll be calling right away, versus whether the least urgent situation for patient 014, it will call in last. So we will assign them to the different bed, then to our available personnel that includes nurse or doctors, and also we'll have a record of how busy these personnel are. For the UI mockups, as presented here, when the patient arrived, they will be handed a questionnaire asking about their medical history, current situation, and so on. So the patient, if they are in an emergency condition, they will call it immediately. If less emergent, we'll add them to the wait queue. This is the showing for the triage form mockup. On the right side is the patient ID card, which I have shown before already. We have also done some research on how to assign the patient to different severity levels, what parameter to be used for ranking algorithms, and existing efficient triage system, and instrument, and etc. So if you guys are interested in this topic, you can look into this paper to see what each paper's like take-home messages. I won't cover all of them for today, but we are welcome to read these papers. So for this Gantt chart, we have successfully finished everything for last project and also this project, and we have a lot of work to do for the near future. Project 2 will keep it updated.